Okay, right. So this week's homework, our second and possibly final one on differentiation for now. We begin with, well, these are both past exam questions, but we begin with one that uses the function notation. So f of x is 4x to the half plus 1 over x cubed. Find f dashed x. So we know that this means, really this means differentiate it once, doesn't it? Find this. But before we do that, the important thing we have to remember, we need to write our equations in index form. We need to write them with clear powers that we can see. Well, that bit's all right. In fact, the question's been quite kind to us, because that could have been written as 4 root x, couldn't it? But we started with 4x to the half. And then how do we write 1 over x cubed before we're ready to differentiate it? What's that, x to the power of, Andrew?
X to the minus 3.
X to the minus 3. Okay, so that's our start. Now we're ready to differentiate it. 4x to the half, we bring the old power down, so 4 times a half gives us 2. Take 1 away from the power. So we have that. And the other one, we're going to bring the power down to the front, so it's minus 3. And what do we get if we take 1 away from minus 3? Minus 4. And there we go, that's 3 marks. Isn't that great? Now it could be that if you were being really extra special about this, you might choose to write it as being 2 over root x minus 3 over x to the 4. And in some ways I'd like to give you bonus marks if you wrote that, but that is just as good. So that would get you the 3 marks, even though that's a slightly nicer way of doing it. The second one, with 2 little dashes up here next to the f, that means we're going to differentiate it twice. We need to differentiate it, having done it once, we need to differentiate it again to get the second derivative. And so staying with these powers, being careful about what's going to go on here, 2 times minus a half, and make that negative. And if we take 1 away from the power, minus a half, take away another 1, is minus 3 over 2. And then this becomes positive again, minus 4 times minus 3 gives us plus 12, x to the minus 5. And it's hard to believe it, but that is another 3 marks. I actually have a suspicion that when I wrote this up as an exam question a couple of years ago, in order to make it be an even number, the number on the paper, I added 1 to the second part, so that may have only been worth 2. I'm not sure. Great, good. That's all the video, isn't it? Next question. Quite a bit of a bigger question here. We've got more to go at. The curve x cubed minus kx squared plus x minus 3 has 2 stationary points. Great. Part 1, find dy by dx. So we're just going to differentiate it. There's no messing around with powers, it's all exactly in the form we want it. So x cubed, we go to 3x squared. Now what happens when we differentiate minus kx squared? What's that going to give us? Minus 2kx, that's right, isn't it? Because the k we just treat as being a whole number, so you would multiply that by the power, so that's going to stay there. Plus 1x, so that gives us plus 1 at the end. There's our 2 marks, that is dy by dx. Now it says, given that there is a stationary point when x equals 1, find the value of k. We've got to unpick this question a bit, haven't we? We've got to interpret this. What does it mean when it's telling us that there's a stationary point when x equals 1? How does that affect what we're going to do next?
dy by dx will equal 0.
dy by dx. So the question's really telling us that when x equals 1, dy by dx equals 0. So now we need to use that to find the value of k. So if we sub that in and put it equal to 0, 3 1 squared minus 2k times 1 plus 1 must be equal to 0, because that's dy by dx. What is that? 3 plus 1 is 4. Take away 2k is 0. So we rearrange this. 4 equals 2k, so k is 2. Great, another 3 marks. Now it says determine whether the stationary point is a minimum or a maximum point. How do we determine whether a stationary point is a minimum or a maximum? What do we use? Say it then. That thing.
That's D2y.
That's the one. D2y by dx squared. Actually, before we do this, shall we write this? We now know what k is. We now know that k is 2. So before we work out d2y by dx squared, let's write this as 3x squared minus 4x plus 1, because if k is 2, that's what it actually is, isn't it? So the second derivative, d2y by dx squared, would be 6x minus 4. And we remain interested in what happens when x equals 1. So if x equals 1, this bit here is 6, take away 4, which is 2. And the important bit is not the value of that, but whether it's positive or negative. Now that is greater than 0, which tells us what? Or what kind of point? Minimum or maximum? A minimum. So we've got a minimum. Brilliant, another 2 marks. Finally, part 4, find the x-coordinate of the other stationary point. The other stationary point we're interested in, 3x squared minus 4x plus 1 being equal to 0. We need to factorise this. Actually, this is one of the easiest gifts of a factorisation you could imagine getting, because we know that one of the solutions to this, one of the factors, is x minus 1. We know that because the question told us that there was a stationary point when x equals 1. So one of the factors must be x minus 1. That's how you get x equals 1 as a root. So to get the 3x squared, you have to do x times 3x. To get a plus 1 at the end, you have to do minus 1 by minus 1. So that must be 3x minus 1. We'll check it. 3x squared, take away x, take away another 3x is minus 4x, and plus the 1. So we've got our stationary points, x equals 1, which we already knew about, and x equals, what value does that give us? A third. So that is the value that we were looking for. Done it. Fantastic. There we go. 10 marks. Really lovely 10 marks. And that's maths.